So first we'll look how we can. So this video will basically show how we can log into the web dashboard that controls the FarmBot, and then after once you have access to the dashboard or the web dashboard of the FarmBot that we have, how you can configure the robot to go to particular locations, how to click pictures, how you can make sequences that can be used. So sequences can be used to go to each location, and then how those sequences can be then used in regimes that can basically be used to automate the process. So, for example, you can set a regime to run every 4 hours, every 5 hours, depending on the duration that we want. So the video, I plan to show the video such that we already have a regime setup that works for us, as has been already tested out to save pictures. Uh, so first, I'll be just go give you the overview of how I structured that system, and then after that, I'll deep dive into how I made each of those sequences, regimes, and how did I set up the exact time at which the regime should run. So first, the web dashboard can be accessed by. So you go to my.farm.bot, and here you can enter the account that is associated with the farmbot. So at the moment, the farmbot that we have is linked to my account, and the password details uh, will be shared to you separately, not part of the video. But for anyone else who is looking at the video, this particular details are for the particular farm bot that we have at our end. So once you enter the details, yeah, once we will enter the details, you will be able to see the web dashboard of our farm bot. And right now it says that it is connected. And so the first thing that we'll see is how we can make the farm bot move. So essentially, if you want to move the farm bot manually, you can press any of these buttons to make it go, or make increase the x coordinate or decrease the x coordinate. Same with the y coordinates and the z coordinates. You can click a picture manually. If I say like click a picture, it's gonna click a picture, and the saved picture can be seen here. At the moment, the plants are too big, and that is the reason why. And the camera is too close to the plant, and that is the reason why you see such a picture. But uh, you need to position the camera correctly in order to take a good capture, and that can be done by increasing the z-axis essentially. But coming back to how you can move the x, y, and z-axis, alternately you can also put the coordinates in these boxes, the x, y, and z coordinates in these boxes, um, and ask it to move. Another thing is that there are these two important icons. One is move to home and one is find home. So move to home will basically make the robot go to its home position, and find a home, basically once you click find a home, the farm bot will assume that it does not know where the home coordinate is. That is coordinate 0 in x axis, 0 in y axis, and 0 in z axis, and it will go and find that coordinate. uh, I will be showing you what this particular coordinate is in our real system and how it is configured, but just assume that it will find the home position for the moment. uh, Now coming to how do we make the sequences. uh, so first, so let's start from the beginning. So this is just the grid. So we need to come here. So we are concerned with this section or this option, which is sequences. And there are once you open sequences, you'll see bunch of other sequences that are already present, such as find home, the other sequences which we don't necessarily use, but are available. And there are some sequences which I've already made, that is take photo first row. So the robot here is has been configured to go to each of the plant location in the first row, and depending on that, uh, after reaching that position, capture the image and store it. Similarly, I have made such sequences for all the rows. Since our NFT channel has 6 rows, we have first row, second row, third, fourth, fifth, and sixth. And then I have used these sequences to make another sequence uh, that will basically, when I run this, the robot will know which position to go for each plant. Go there, take a picture, and go on to the next row, or just terminate the process. So first we'll take a look at how I made the first sequence of the sequence to make the first row. So when I open this, the first thing that you can see is run and the save. But the run basically means that once you run this, it is going to follow all the instructions that have been given here. This is I feel the most simplest way to make the farm bot or program the farm bot rather than writing Lua scripts or Python scripts. And it's a very good and easy point to start rather than just deep diving into writing code, Python code to make it move. Ignore this error message for the moment. This does not concern with what we are trying to do. So first, let's just focus on what these blocks are. Later on, I'll be in the further video or in another video, I'll be showing how to add these blocks. But right now, let's just focus on what these blocks are. So first block is move home. This is the name has been given by me. What I want is like this first row. So the sequence of taking the picture starts at the first before the first row. So I what I want is like i- the robot to go to its home position at at the beginning of every cycle of capturing pictures. That means that let's say that they were due to some error or due to manual termination, or like if the electricity is lost during a cycle, in between cycle, or for some reason the robot has been terminated which is not its natural position, the robot at each sequence will always go to its home position before starting the cycle. What this ensures is that in the upcoming blocks we'll see that the location that the end effector or the camera needs to go is in terms of offsets. This is one of the design decisions that we chose, that we can give the new location in terms of offsets. That is like after going to one particular coordinate, just go away from that coordinate this much units in x direction, this much units in y direction, and this much units in z direction, and the units are decided by us, rather than going to absolute positions. What this does is that if there are some changes in your system, like the first coordinate changes, let's say due to we decide to change the actual hardware design of the channels, or we decide to move the location of the channels, you just have to go and change the first coordinate. And after that, since the NFT is manufactured by Crop King, the distance between the two slots where the plants exist are gonna remain the same. So as long as you just change the first, calibrate the camera and like change the location to the of the first coordinate, you don't have to make any manual changes in the upcoming distances. So let's start from the top. So first is the block for the robot or the end effector to move home. So first, what I say is that robot will go to the location 000. That is the ideal home condition, but just for distance sake, I have given the first coordinate of the home coordinate to be 1 in x, 1 in x, 1 in y, and minus 1 in z. So one thing to note here is that the z-axis is inverted in our case. I have structured the robot to be such that the z-axis is inverted. That is, as the camera keeps on like z-axis going like keeps on going down, the value keeps on increasing in the negative axis. That is, well, like you see, if I want the camera to go from its home position downwards, it goes to minus 50 rather than positive 50. It's just much easier to visualize because the z-axis is actually lowering, and lowering can easily be like assumed with a negative direction. So first, it is go to the home position. The next block, which is like the move block, it says that it goes to these dimensions in the x, y, and z axis, and these values can be manually entered. So this is something that like. Let's assume that you are doing something from scratch, or doing something, or the locations that the camera are not known to you. What you can do is you can manually change these locations, go to any location, then try to capture a picture. If you think that the camera is actually capturing a good area of where the plant might grow, you can use that location as the first location, and then after that, since the channels are perpendicular, you can just keep on increasing the distance in y-axis. I'll show you how. So the first coordinate that I found out of the channel is 80 mm in x-axis, 140 mm in y-axis, and minus 50 in z-axis. Once the robot reaches here, only then it will execute the next block, which is to take a photo. And take a photo will basically stop, take a photo of the RGB camera, then upload it to the web dashboard. But for what we are concerned with, we just have to add this one particular block that will take a photo. Then again, I want the camera to move to the second plant, and the distance offset between the two slots in the NFT channel is 200 mm. So there are different, so the move block has different options. You can enter custom coordinates or offset from current location. So I chose the offset. So this basically means that from the first position, which is this position, the camera will move 200 mm in y-axis and then take a picture, and so on and so forth for six of the different slots where the plants are growing. This sequence is followed. So, other than the move home option, this sequence is followed for all the plants. So, this is for the first. Then, after that, you for the first plant, you set absolute locations, and after that, you do the same thing for all the plants in one row. So, this is for the first row. Now, when we look at the second row, uh, so if I go and open the sequence for the second row, here you will find that there is no homing since the execution has already begun. We don't need to home the robot. Rather than that, we can just give it the absolute coordinates of the plant in the second row in the first column. If we visualize it as grids, then this is the first plant in the second row and the first column. So these are the coordinates that I found out by manual testing the camera, moving the camera, and checking whether the RGB camera is right above the plant. Then after that, we take a photo and we do the similar thing like 200 mm offset for all of these six plants. So this similar thing is also done for the third row, for the fourth row, for the fifth row, and the sixth row. And once you have everything for all the six rows, I use these six sequences to make another sequence, which I've named entire grid photo, where I've added the sequence as a combination of these subsequences, that is sequence to take the photo for the first row, then the second row, then the third row, then the fourth row, then the fifth row, and then the sixth row. And what happens is, if I just run this individual sequence, that is take photo first row, the camera will go to each location in the first row and just capture the images for the six plants and stop. Similarly, if I do it for the second row, it's going to do the saving the pictures of six plants for the second row. But once I execute this, it's going to execute all these sequences one by one. So first row, second row, third row, fourth row, and fifth row, sixth row, and then it's going to stop. So what this basically does is that how this is divided is that, like, if in the future there are some changes in locations or coordinates or the way that the farmer is moving, we just need to change some parts at the lowest level. That is, we just need to change um, the location in the of the first coordinate in the first row, the first coordinate in the second row, the first coordinate in the third row, so on and so forth for all the six rows. And whatever we automation or whatever sequencing or regimens we are going to do in the future, we are going to use this sequence, that is the entire grid photo. And by doing so, we essentially ensure that by going forward, whatever changes we make or whatever we do is with the higher level sequences, so that if there are any changes, we don't need to make changes at each and every sequence. Rather than we just can just go to the lowest level of where the change needs to be made and change that. This is going to be all for the first video. The second video will explain how you can make new sequences and how you can place the coordinates for those sequences.